Welcome back, dear students, to this concluding lesson on the chapter Computer Organization and Architecture. Today, we are looking at the addressing modes. Okay, we know that a machine instruction specifies to the CPU what to do, where the data is located, and where the output data, in case we have, will be kept. That's what a machine instruction specifies to the processor. Operands can be specified in different ways in an instruction. The way an operand is specified in an instruction is known as an addressing mode. The addressing mode specifies the way in which the operand will be interpreted. That's the definition I say of an addressing mode. It's simply a mode that specifies the way in which the operand will be interpreted by the processor. It indicates to the processor how to locate the operand associated with an instruction. As you can see, we saw that an instruction is divided into two parts, the opcode and the operand, which is still the case. But the opcode is um further divided into the instruction itself and the addressing mode. And this addressing mode specifies the way in which the operand has to be interpreted. If it has to be interpreted as a value, as a memory location, as a reference to memory location, that is what we are going to see in this lesson. There exist several addressing modes, but the five most common are: the first type is immediate addressing. In this addressing type, the operand is given explicitly in the instruction. That is, the value to be manipulated by the instruction is immediately part of it. There is no need for additional information. As an example, we have multiply arrow2 arrow3 times and hashtag 5, which means we are multiplying 5 to the content of arrow3 and we store the result in arrow2. The symbol hashtag is used here to indicate immediate addressing, as you can see. So when we talk of immediate addressing, the operand we are precising with a value already represent the value, or you can say the constant to be used in the operation. The direct addressing. With this type, the operand specifies the address of a memory location. The content of this memory location will be used in the operation. It is also called absolute addressing mode. So in contrast to this one, you see that here, this hashtag 5, the 5 simply means that what the value 5 is the value I will use in the multiplication operation. But when it comes to direct addressing, what we have is instead the address of the location of the value we are to use. Like for example, load R1 $0 AE. It simply means that what? I'm going to load into R1 the content of this memory location. That's what it means. So we load the content of the memory location of 0 AE into R1. The symbol dollar sim is used here to indicate direct addressing, but it's not in all cases that they will use this symbol. But in case they use, you should know that what it means direct addressing. As you can see. So when we are given an instruction, we have our opcode, we have our operand. The operand value that we have, in case they're addressing, that operand value you have is simply the address of the operand. So here is supposed to be operand, the value you are going to use. So here is supposed to be the value you are supposed to use in the operation specified by the opcode. So as you can see, this diagram is illustrating it. Then we have indirect addressing. In this addressing type, the operand specifies the address of a memory location or register which holds the address of another memory location. The content of this second location is used in the operation. So let us go back to the beginning. In immediate, the value they are giving me is the value I use directly in the operation. In direct, the value they are giving me is the address of the value to be used in the operation. But when it comes down to indirect, the value I have in the instruction is the address of a memory location. That memory location itself contains the address of another memory location which contains now the value to be used in the operation. So it's just like here, I have A, I use A. Here I have A. A tells me that no, go and use B. I use B. Then here I have A. A tells me that no, go and see B. But B tells me no, it is C you're supposed to use. So I go and meet somebody that tells me to meet another person. That's how indirect mode is. So here I have add R1, R2, R3. So here I add the content of the memory location held in the register R3. So I'm not adding the the content of R3. No, I'm adding the content of the memory location held in R3 to the content of the register R2, and the result of the operation is held in R1. So as you can see, so this brings me to in memory location C, I have A, and now I come back and I use the content of A. So here it's supposed to be value, not opcode. So it's supposed to be any value. This is how indirect addressing is illustrated. The operand specifies an address, and that address contains another address, as you can see. We have indexed addressing. In this type of addressing, the operand specifies the address of a memory location. The content of the index register is added to the address to determine a second address. The content of the second location will be used in the operation. So here, in contrast to indirect, where I have an address bringing me to another address, here I am using a particular value stored in the index register. I add it to the content of the address specified in the operand that gives me a new address. So for example, load R1 12 into R2. This instruction loads into R1 the operand that is found in the memory address obtained by adding 12 to the content register R2. So if R2 contains, for example, 13, then I will load the content of the memory location 25, that is 13 plus 12. That is what will be loaded into R1. And this is the illustration. So I have my index register, I have my address. In my index register, I take that value in the index register and I add it with the address. As you can see, it will now generate me a new memory location, and it is the value at that memory location that I'm going to use in my operation. We also have the I think it's the relative addressing. But the difference with the relative addressing is that instead of using an index register, you are using the program counter. Now, the register addressing. In register addressing mode, the operand is the content of a processor register. The name of the register is given in the instruction. As example, we have add R1, R2, R3. So here we are, the registers R2 and R3 hold the sources operand, while R1 holds the result of the computation. So this one is easy to understand. Now, summary of addressing mode and their effective addresses. Take note of part 1 and part 2. So each of these addressing modes, this is a table summarizing how to obtain their effective address. For immediate, there is no effective address since the value we are given is what is used in the operation. In direct addressing, the effective address of the operand is given in the instruction. In indirect, the effective address of the operand is the content of a register that is specified in the instruction. When it comes to index, the effective address of the operand is generated by adding a constant value, and that value is stored in the status in the index register to the content of a register. So we take the value stored in the index register, we add it to the content of the register specified in the operand. In register mode, the effective address of the operand is the register and not the content of the register. So here, when we give a particular register value, it is directly the effective address and not a content, like it is the case for direct, indirect, and index. So I hope throughout the journey of computer organization and architecture, you learn a lot, dear students, because we are coming to the end. And in the last video, we are going to see some examples for deep understanding on addressing mode. Do not forget to like, to subscribe, and to share. And be massively present for the last video where we shall have more exercises, be it regional mock or GC question, that will enlighten us more about this particular and very important chapter. Thanks, and see you in the next video.